For our synthesis of aspirin experiment, we're going to use a 50 milliliter flask to put our reactants in and do our reaction. The first thing we'll need to do with it is to weigh the flask empty. And so on your data, that is A, and that is in grams. Then we're going to weigh out about 2 grams of salicylic acid. We will we'll watch the number, but we're not going to really write that one down because we're going to get the true mass of the salicylic acid that actually makes it into the flask, so we'll be more sure. And you may notice that salicylic acid is a white powder, like a lot of organic acids are. Next, we're going to put our salicylic acid into our flask and we're going to weigh it again. And so the mass of the flask with the salicylic acid only is your data that we have labeled C. So after we weigh that, and now we can subtract and get our true mass of our salicylic acid that is in our reaction flask, we're going to add a few more things. First, we're going to add acetic anhydride. A lot of times we abbreviate that AA as opposed to SA for the salicylic acid. When we do this, we're going to get 5.0 milliliters of that. And so we only have 2 sig figs on that one. The other thing we're going to add is our catalyst. Our catalyst is phosphoric acid. It is not considered a reactant. It is a catalyst in that it helps the reaction go faster. It's not consumed by the reaction, it's not used up, and it just takes a few drops to do that. The reason we do that is to make the reaction go faster. Without the catalyst, the reaction might take all day. Next, we're going to dip our reaction flasks down into some warm water, and the water will be about 75 to 80 degrees Celsius. The reason that we put it in some warm water is because that will speed up the reaction if we warm it. We don't want to go too hot though, because if we do, when the aspirin crystallizes, it won't be in little powder crystals. It'll be kind of waxy and it will be hard to separate and get dry and stuff. So anyway, we have it dipped down into this warm water, and at this point the salicylic acid, the powder, causes this to just go clear, so it just looks like water in there. And here is a picture of the actual setup as we say that our aspirin is cooking in that little flask. After we let it cook for 15 minutes, we're going to add some water, cold water to it, and which will deactivate any leftover acetic anhydride. It will make it turn into acetic acid, which is basically the acid in vinegar, so it makes it a little safer. But also the cold water is to help it crystallize. After we add some cold water to the flask, we dip it down into an ice water bath. When you use the glass rod to rub on the bottom, we call that scratching it. It helps the crystals come out of solution. So when you do this, you'll start seeing the white substance in the flask. And here's a picture of what that looks like. This white substance that we see there is the aspirin. Next, we're going to set up our vacuum filtration apparatus. To do this, we use a vacuum flask, which has a little side arm on it. And then we use a Buckner funnel, that's this. It is a funnel, but inside of here, it has a flat base. So what you do is you use a round piece of filter paper. And you put that down into this flat bed. The flat bed has little holes in it, but they're too big. So you put the filter paper down in there and you wet it so that it makes a good seal, so that when you filter, everything has to go through the paper, the liquid. And then this is connected to a tube which is connected to the spout on the sink. On the sink where the water comes out, and we're going to need to turn it on high, but just to kind of show you, that's where the water comes out. There's a little side arm, and this hose needs to connect to that. And what happens is that when you turn on the sink, and you'll turn it on really hard, the water will come out here, and when it does, it will pull air out of this tube, and which of course pulls air out of the vacuum flask. So it creates a vacuum down here, which essentially pulls your solution. You'll put your solution in here, it'll pull the liquid part of your solution through. So it's kind of a power filtration. And I should say, we tend to think of the vacuum as pulling, but it's really not that. It's that it's a lower pressure in here than in the room, so the atmosphere is pushing your solution through. Here's what that actually looks like, and the only difference is here, and it's kind of hard to see, is that we do have a trap, and the trap is actually between the flask and the sink, but this is your Buckner funnel. So once you have that set up, you're going to pour your crystals and the liquid that's left out of your reaction flask into the funnel. Any of the crystals should stay up here on top of the filter paper, and then the liquid, which is going to be water and any unused reactants, will come out the bottom. This is what it looks like afterward. This is viewing the Buckner funnel from the top, and you can see we have our white powder crystals, which are the aspirin. We dump out our aspirin crystals onto a paper towel to dry them, and this is what they look like. We will be putting our aspirin crystals on a watch glass to weigh them out, and so the first thing we're going to do is get the mass of the watch glass. The mass of the watch glass with nothing on it will be given as the number B, and that is in grams. Next, we put our aspirin onto the watch glass and we weigh it again, and this will be D for the numbers you're given. And also you should note what the aspirin looks like. That's part of what you need to use to say that, yes, I did make aspirin. On your conclusion, you should include your theoretical yield, your actual yield, your percent yield, and your observations about what this looks like. All of those go into whether or not you made aspirin, which was your goal for this experiment.